Hello and welcome to StatLab StatCrunch videos. Today's video is about section 2.5, which is measure of position. So I am on homework 2.5, problem number 4. So if you have to work with me, I would suggest to pause the video, open your homework, and we can do it together. All right, so let's move on and see what the question is. Use the accompanying data set to complete the following actions. Find the quartiles, find the interquartile range, identify any outliers. So before I go ahead and start and tell you what they are, I would like you to go ahead and open the data in StatCrunch. And how do we do that? I'm going to click on the double windows, open StatCrunch. I'm going to keep my window minimum so y'all can see what I'm talking about. So here I have my data set. What I'm going to do is I'm going to go ahead and sort it. So I click on the icon right here and sort ascending. So you see that I have data sets from 15, 29, all the way up to 55. So first they're asking us to find what quartiles are. So the word itself tells you that Q1 is the first quartile, Q2 is the second quartile, Q3 is the third quartile. Now you might say, Miss, what is a quartile? Just like the value of a quarter is 25, quartile is 25%. So when I say Q1, I'm talking about the first 25% of the data is before Q1. When I say Q2, 50% of the data is before Q2. When I say Q3, 75% of the data is before Q3. Okay, so let's go ahead and see how this is done. You can go ahead to StatCrunch and Summary Stats, but I like to use a graph here. And the graph that I use is graph. I go all the way to box plot, and I want you all to pay attention here to see what I'm doing. I'm going to check on the variable. You will check use fence identifiers. Let me see what they are. Use fences to identify outliers. You will use that, and you will also click on draw boxes horizontally, and then you will compute. I'm going to use a red color here so you all can see. And I'm going to go ahead and click compute. So this is what my box plot is going to look. So let me explain what the box plot means. What I want you to do is move the mouse to, you might have a dot up here, or some of you might have a dot all the way to the other side. It depends on your data set. So let's go and talk about it and see what each of them mean. So I'm going to go ahead and click on my box here and just leave your mouse. So you will see that when I click on it, it will tell me how many values I have, right? It's going to tell me how many values I have. It's going to tell me how many outliers I have. It's going to give me IQR, lower limit, Q1, median, Q3, upper limit. So let's go ahead and talk about each one of them. So the dot that you see, let me pick my pen here. The dot, where is my mouse? Okay. The dot that you see here that is not with your data set is your outlier. That means the data value is either too low or too high with respect to this entire data. The first line that you see, this line here, is your minimum value. The second line is your Q1. Your third line is your Q2, which is also called as your median. So let me write that down. Your Q2 is your median. Oh, my handwriting. The third line is Q3, and this is your upper limit or the maximum value. So Q1 is 25%, Q2 is 50% percentile, and Q3 is 75 percentile. Okay, so let's go ahead and see how we can fill this up. They asked me for Q1, so I'm simply going to go ahead and put my graph on here. Oops, clear that. And if you see that, my Q1 is 36. So I'm going to go ahead and look for the data 36 here. Let me expand this. Oops. So look at 36. So when you see 36, I have 25% of my data before 36. Now Q2 is your median. My median is 40. My median is 40. That means I have two numbers. So I divide 41 plus, and I divide 39 and 41, so I have two numbers here. My median is 40, so somewhere right here. So when you look at it, my median is exactly the middle number. And remember, if you have odd numbers, you add both of them and divide by 2. So in this case, I have 39 plus 41 divided by 2, which gives me 40. So my median is 40, and I have 50% of the data before the median. And my Q3, the third quartile, is 45.5 Q3. So somewhere here, I'm guessing, and I have 75% of my data before that. Okay, so what I'm going to do is I'm simply going to go ahead and plug that in. So my lower limit, no, they're asking me for Q1. Q1 is 36. I'm going to go back to my graph here. My Q2, remember, you will not find Q2, you will find a median. Your median is 40. And let me see, my Q3 is 45.5. And I hope you're seeing where I'm getting those values from. 45.5. And then I check my answers. Well done. They ask me for interquartile range. So let me go ahead and see what that is. So when I move my mouse, I will see something that says IQR. Do you see that? It says IQR 9.5. So IQR is your interquartile range. So range means maximum minus minimum. Quartile range is the range between your quartiles. So your quartile range here, your IQR here is simply Q3 minus Q1. So whatever is your Q3, which is 45.5 minus 36, that is going to be your IQR. Okay, so I'm simply going to click this one here and move your mouse. You see my interquartile range is 9.5. So 45.5 minus 36 is 9.5. Perfect. And they say, identify any outliers. Now, once they ask me, I'm going to go back to my graph and click on it. And it says, yes, there is an outlier. You see, it says one outlier there. Yes, it does. And what is my outlier? The number that the dot that I see right here that acts like it does not belong to the group, that's my outlier. And if I want to know what that is, you simply move your mouse over that. And you will see my outlier is 15. There you go. Okay? All right. So from this graph, you should be able to find all the values here. This is your minimum value. Remember, the first one is your minimum. This is your Q1. This is your Q2. This is your Q3, and this is your maximum. Q1, Q2, Q3, your max or the upper limit or the minimum value. This is the minimum value. All right, you should be able to go ahead and fill that out. This is the one that I want to do. So this is a Box-and-Whisker plot. We did discuss about normal distribution. We did talk about skewed left, skewed right. So given a Box-and-Whisker plot, how do you know if it is skewed left or skewed right? So what I would do is I would simply start from one end and see where my curve, where's the tail? My tail is going to the left. Do you see that? So I start from here and my tail goes all the way to the left. So this distribution is skewed left. I'm going to have to clear this part. Close this, skewed left. Okay, now if I click on similar question and I would like to show you how skewed right looks like. So you simply start from one side of the graph, correct? And I'm simply graphing and you see where the tail is going to the right, so it's skewed right. There you go. All right. I would, let's see. What did they say? No, you can go ahead and do that. Yes, I would like to do problem number 11. So in this problem, it says the data shows the number of hours spent studying per day by a sample of 28 students. And this is use the Box-and-Whisker plot to answer the following questions, they say, okay? And I'm going to go ahead and click on it. And there are two ways of doing it. If you all want to go ahead and graph it, you all can do that. Or if you think you can pull your information from here, you can do that. But I like to go ahead and graph it. So I'm going to open my data in StatCrunch. Graph. Remember, it's a box plot. Box plot. Click on the variable. Remember, you have to check draw boxes horizontally. And I compute. And once I have that, I'm going to get it closer and leave my mouse right here. So what I want you all to see here is, I want you all to see that my Q1 is 2.5. That means 25. My first quartile is 2.5. My second quartile, which is my median, is 4. My third quartile is 7.5. Remember, first quartile is 25%, second quartile is 50%, third quartile is 75%. So in this question, they asked me about 75% of the students studied no more than how many hours. So when they say 75, it rings a bell. I know it's third quartile, which is 7.5. Oops, how do I answer this? Okay, 7.5. And I check my answer. Fantastic. I go back to the next question. What percent of the students studied more than 4 hours per day? I'm going to go back to my graph and see. 4 is my median. So median is 50%. Okay, so 4 is 50%. So 4 hours per day is 50. Where is 50? Right here, 50%. Check my answer. Very good. And they said, you randomly select one student from the sample. What is the likelihood that the student studied less than 2.5 hours? So when I'm going back here, so you have a bunch of students and you select one and you're trying to see what percentage does he have less than 2.5 hours. So when I say 2.5 is my first quartile. First quartile is 25%. So the chance that student would study less than 2.5 hours is 25%. And there you go. Okay, so you always have to graph it and pull your information from your graph. You all can do this. Okay, now this is one thing that I really want you all to focus on. We're going to be talking about a new topic. So let me have my pen ready. We're going to be talking about a new topic which is called z-scores. Okay, so let me have my pad here so I can write down. So the topic today is going to be z-score. So what exactly is z-score? If I ask you, how far are you from school? You would say, one would say 5 miles, right? Or someone would say, let's say 20 minutes, correct? So one is using miles and the other one is using minutes. Both of them are correct. So these are the units for measurement. You see that? These are units for measurement. So if we come back to z-score, z-score is nothing but if this is my mean, z-score is the distance from the mean in terms of your standard deviations. So z-score is nothing but the distance from the mean in terms of your standard deviation. Z-score is nothing but the distance from the mean in terms of your standard deviation. Now, if I say that, let me go ahead and change the color here. Oops, where is it? Yeah, I want to get a red color. Yeah. So if my z-score is 1, that means I'm 1 standard deviation above the mean. If my z-score is 2, I am 2 standard deviations above the mean. If my z-score is 3, I'm 3 standard deviations above the mean. If my z-score is -1, I am 1 standard deviation below the mean. if my z-score is -2, I'm 2 standard deviations below the mean. So the positive sign tells you you're above the mean. The negative sign tells you you're below the mean. Okay, now when do I use z-score? Majority of my data is normally distributed. That is a bell-shaped curve which we went over in class. So if your data is normally distributed, then this data will follow the rules of the z-score. Okay, so let's go ahead and see how we can go ahead and look at the z-scores or calculate the z-scores. I'll have to erase everything here. Oops. Okay, and the formula for z-score is x minus mu over standard deviation, where x is the value, mu is the mean, and sigma is your standard deviation. Now let's go ahead and look at the problem here. The age of the winner of a cycling tournament are approximately bell-shaped. So we know it's a normal distribution, so we know z-score follows. The mean age, I write as I read. So the mean age is 28.4. The standard deviation is 3.7. Okay, so this is the information we have from the cycling tournament. Now how are we using it? The winner in one recent years was 24 years old. In recent years, X is 24 years old. They want us to transform this into a z-score. But before we go ahead and do that, we need to see why. Why do we need, oops, my mic is falling down. Why do we need a z-score? If you ever looked at your blood report or something, then usually they have different colors. One, they will have a blood report in green saying that you're okay, and then you have a blood report in orange. Oops, where that's yellow. You have a blood report in orange. That means you have, this is orange, guys. It's not, orange is not working for some reason. Yeah, orange. You have blood report in orange saying that you're borderline, and you have a blood report, like the colors of the blood report, that say if it's red, that means you have to start working. So how do they come up with what is correct and when should I know? So that's what we're going to be talking about here. So z-scores, I'm going to use a black color so y'all can see. You know what? I'm going to use blue here. So I have a z-score. This is my mean. So if I'm 1 standard deviation, if my z-score is 1, I'm 1 standard deviation. Z-score is 2, 2 standard deviation. Z-score is 3, 3 standard deviation. -1, that means 1 standard deviation below. -2, 2 standard deviations below. -3, 3 standard deviations below. Okay, so let's look at an example here. You're buying a house in Arlington, and the house is, let's say, 100K. The mean value is 100K. And your standard deviation is, let's say, 20K. That means the houses range from 100, 120, 140. So let's go ahead and look at it. So the first house, if my standard deviation is 20K, my first house would be 120K. Do you see that? My second house would be 140K. My third house would be 160K, 3 standard deviations away. If my standard deviation is below, my first house would be, where is it? 80K. Do you see that? My second house would be 60K. My third house would be 40K. Oops, my pen is not writing. 40K. You get the idea here, right? So what I'm trying to tell you is, how do I know what is correct? So if you're trying to buy a house for 100K, you are okay with 120, right? You are okay with 80 because that seems pretty normal. When you go to 140, you're okay, still okay with 140. You're still okay with 60. But if you go past 140 or past 60, that is, if your house is 150K, or if your house is less than 60K, which is 50K, then you start to have questions. You think, something is probably wrong with the house, and that's why the house is so less. So what I'm trying to tell you here is, let me use a different pen. This is not letting me do it. What I'm trying to tell you is, if you are in the range, if you're in the range of -2 to +2 standard deviations, then you feel it's quite normal. So you started with 100 and you know the standard deviation is 20. So you can still buy a house that's 60 and 140. So anything beyond that, when I say anything beyond that, that means if you have something, oops, my pen. If you have something beyond that, between -2 to 3 and +2 to 3, this part is very unusual. So if you go beyond 2 standard deviations above or 2 standard deviations below, then you're going to say, that's either too high or either too low. That's unusual for a house. Do you see that? And let me go ahead and change the color here. And if you have something that is less than 40K, that means if it's like 30K or more than 160, which is 170, then that is very unusual, because your range is 100. I mean, your mean is 100, your standard deviation is 20. And if you look at a house that is 30K, that's way too less. Or if it's 160, that's way too high. So that means that is very unusual. Why I'm telling you about these standard deviations and usual and unusual is, if you are in the range of -2 to +2, then that's normal. If you are in between, if you go beyond -2 and more than +2, then that's unusual. But if you go below -3 and above +3, that is very unusual. Okay? All right, so let's go ahead and do this problem here. Let me go ahead and erase this. I'm gonna write this down again. Z-score, the value of Z-score is X. What's happening to my mouse? Just give me 1 second here. All right, got it fixed. Let's see how it works. So my Z-score, Z is equal to, not working again, X minus mu over standard deviation. So my X value is, we saw that before, this is my X value, this is my mu, and this is my standard deviation. So my X value is, so we're trying to see my Z-score. So just by looking at the value, I know it's below the mean, correct? So I know my Z-score has to be negative. So I have 24. For some reason, this is giving me a hard time. 24 minus 28.4. I'm sorry guys, I have to pause here for a second and redo it. My mouse is just not working. So let me just do it with this one here. Z-score is, nope, Z-score is X minus mu over standard deviation. So that is 24 All right, so I somehow got it fixed. And so the Z-score is X minus mu over standard deviation, correct? My X is 24, mu is 28.4, and standard deviation is 3.7. So when I go ahead and do that, I end up with negative 1.19. So my Z-score is negative 1.19, and I have to go ahead and plug it in here. So let's go ahead and do that. So my Z-score is negative 1.19. Check my answer. Fantastic. And I have to interpret my results. The negative tells me that I am below the mean because I can clearly look 24 is way below 28. So it is 1.19 below the mean. Very good. And now they're asking me 1.19 whether the age is unusual. So remember what I told you. If this is your z-scores and if you are, I'm sorry about the emails, if you are -2, and again it's not writing, -2 to +2. If you're in -2 to positive, in the range of -2 to +2 z-scores, you're okay. If you're above +2 or below -2, then it's unusual. But in this case, -1.19 is somewhere here, so it's not unusual. So no, this is not unusual. Let's see which one would that be. No, this value is not unusual. It's outside the range. No, it's in between the range. So I'm going to go ahead and click in between the range. And oops. Oh, no, it's not unusual because, sorry. No, it's not unusual because it's in between the range of -2 and +2. There you go. Okay? Hope this helps. Perfect. So I want you all to go over this whole video slowly at your own pace and complete section 2.5. All right? I'll see you in class.